Now that the preparation's done, it's time to get started on your workpiece. Switch on the machine for the operation. The controller will boot and the machine will take the home position. This can be either 0 or any predetermined setting. Correct it to 0, 0. Next, set the home position of the tool turret using the switch provided on the keyboard. Give the commands of the feed or jogging as the case demands. Use the control key to switch on the foot pedal. In case you make any mistakes or accidents, use this red color emergency switch to turn off the machine immediately. The yellow-colored highlighting on the screen indicates the axis on which you work. Moving on, set up the tools. Here we have used an 8-tool holding turret that holds both square and cylindrical shanks. Begin by fixing the square-shanked tool in the turret slot. Use the taper sleeve tool tightening arrangement for square-shanked tools. The taper sleeve moves and the tightening grip increases or decreases accordingly. Use the Allen screws to clamp the shanked tool. This shanked tool has an outer diameter or facing carbide tip. Tighten the Allen screws using the Allen key and ensure the tool is properly clamped. Bring the empty turret slots towards you. Go on to load the taper shanked twist drill, also called the helical drill. In order to facilitate fixing, insert the sleeve matching the taper of the drill into the block. Go on to fix the helical drill in the sleeve. It will automatically take the position. Tighten it and ensure it is firmly held. Similarly, mount the rest of the required tools. The turret is now loaded with all the required tools. The lathe machine has a number assigned to each slot, so pay careful attention to where you place each so you can note the information on the tool screen. Proceeding ahead, fit the jaws in the chuck. Here we have used the 3-jaw self-centering chuck to set the workpiece. The chuck has got 3 guideways on which the jaws are fit. The guideways and the jaws are serial numbered and the same numbered jaw has to be fixed on the corresponding guideway. Tighten the jaws on the matching guideway with the help of Allen bolts. Take care while fixing the jaws and ensure that they are all concentric. Once all the jaws are fastened, fix the dial gauge on a stationary plane and check their concentricity. You must decide which side to machine first as per the sequence of the operation. Review the drawing and calculate the length of the workpiece that should be left outside the jaws. Remember to leave some additional margin. Measure the length with the help of a steel scale. Demarcate the area that has to be left outside the jaws of the chuck. Use the foot pedal to open the jaws of the chuck. Keep the marked length outside the jaws and clamp the workpiece. Ensure it is held tightly. Start the operation from the home position of the tool turret. At this point, the screen shows 00 everywhere. Continue by setting the reference point or 0 point and slowly allow the first tool to come to the raw material. As per the sequence, the first operation is outer diameter or OD turning. Therefore, first set the referencing point for the OD carbide tip. Bring the tip of the tool as close as possible to the end of the raw material and reset the Z-axis to 0 on the main program page. Remember, you must set individual tool offset position for each tool in the program every time you change the workpiece position or the tool position. Start the machining operation by taking a skin touch on the outer diameter. If the raw material is not concentric, increase the depth of cut to ensure complete exposure of the freshly shredded surface. It is this point that will be treated as the tool offset position for OD turning. Go on to measure the diameter of the workpiece using the vernier caliper. This will show you how much margin do you still have available for further turning. In this case, the diameter reads 48.75 mm on the vernier caliper. Moving on, set the tool offset for center drill, helical drill, and facing tool bit. Feed the positions in the controller. The machine is now ready for automatic operation as per the planned sequence. Go on to perform a dry run for OD turning. Consider the diameter you will require for external threading. Complete the OD turning as per plan. As part of the program, the coolant will automatically start pouring during the turning operation. Perform the center drilling operation to make a point on the face of the workpiece to guide the drill. Moving forward, create a bore that is large enough to allow internal boring and threading. Here, a hole of diameter 20 mm is being drilled. Switch off the coolant on intermittent time intervals to see if the operation is going as per plan. Spring-like chips will come out as a result of drilling continuously. Moving on to the boring operation. First, set the tool offset position. Simply resume the program to conduct the boring operation. Perform the boring operation with extreme care, using small depths of cuts to avoid tool bit damage, as it has a tendency to bend. You will notice the boring tool is going in slowly to the depth but coming out rapidly. This is called rapid feed. The program is registered to do so to save time. Measure the depth and see if it is as per the drawing. Here, the vernier caliper shows a depth of 26.93 mm and diameter of 31.92 mm. Continue the operation till the required dimensions are achieved. Commence with internal grooving. Once again, set the offset position and resume the program. Here, take a look at the piece. It is slowly coming to shape. Proceed with the internal threading operation. Set the offset position and resume the program. Again, small depth cuts need to be made to avoid tool damage. But in this case, the tool moves in quickly but will have to move out slowly with reference to the pitch of the thread. Here, take a look at the complete threading. Once you have made an internal thread, go on to check the thread with respect to standard. Specific thread gauges are available for checking thread geometry and pitch and form, go and no-go thread gauges. For this thread, we have the internal thread gauge of metric 33 by 1.5 mm. A quick check shows that the threads are cut out just fine. The operations sequence planned up to this stage is now complete. This is how the workpiece looks, as in comparison to the original mild steel rod we had first started with. Switch the side and reset the workpiece by using the foot pedal. Ensure it is held firmly in the jaws. Once again, use the dial gauge to ensure concentricity of the workpiece. If you see a variation that is within general tolerance, continue with the operation. Here the variation seen is 200 microns, which is within the acceptable limits. Redo the tool offset settings for all the tools that will be used in further operations. Start with the OD turning. Once that's completed to the required size, you will have removed around this much scrap. Going forth, perform the taper turning operation. In this case, the program is so written that the taper turning combined with OD turning steps are all performed in one go. Give the workpiece a finishing cut to give it a gleam. Check to see if any burrs are left on the surface and deburr any sharp edges. A thorough operation will result in a burr-free piece. The only burrs left are around this edge here. Continue making the workpiece by executing the center drilling operation. Once the center drilling is completed, forge ahead with the external groove cutting operation. This cut is also called the plunge cut. Check the finishing. It's now time to get on with the third part of the machining operation. Workpiece has almost come to shape. This is how it looks in contrast to the raw material at the onset of the machining operation. Once again, change the workpiece setting. But this time around, you will have to replace the hard jaws with the soft jaws. This will ensure that no marks are left on the finished surface, as may be the case if you continue to use the hard jaws. Check to see if it is clamped properly. Perform the external groove cutting operation to make a groove along the edge here. Subsequently, perform external thread cutting, making systematic cuts along the surface. Use the external thread gauge to check thread accuracy. As per the engineering drawing, we have used a metric thread of M42 by 1.5 mm. Move the thread gauge over the external thread and see if it moves smoothly over it. Moving towards the end of the operation, execute the parting operation. Select the tool as per the wall thickness of the workpiece. Here we have used the external groove cutting tool to perform parting, as the thickness of the external groove cutting tool bit is adequate for the wall thickness of the piece. Finally, implement the chamfering operation of the internal diameter and outer diameter. Use the boring tool to perform the internal diameter chamfering. Carry out the outer diameter chamfering using the OD turning tool. Finally, remove the workpiece. Use this practical guide to lead you through the complete process of machining a component. Here is a recap of the broad steps you need to perform to complete the component. Step 1. Switch on the machine. Step 2. Set the home position of the tool turret. Step 3. Set up the tools. Step 4. Fix the chuck jaws. Step 5. Check concentricity. Step 6. Demarcate the workpiece length. Step 7. Set up the workpiece. Step 8. Set tool offset for the first operation. Step 9. Perform the skin touch on the outer diameter. Step 10. Assess the available margin. Step 11. Set tool offset for the subsequent operations. Step 12. Perform the outer diameter turning. Step 13. Perform the center drilling operation. Step 14. Perform the boring operation. Step 15. Perform the internal grooving operation. Step 16. Perform the internal threading operation. Step 17. Check thread accuracy. Step 18. Reset the workpiece. Step 19. Check concentricity. Step 20. Redo the tool offset settings. Step 21. Perform outer diameter turning operation. Step 22. Perform taper turning operation. Step 23. Give a finishing cut. Step 24. Check for burrs. Step 25. Perform center drilling operation. Step 26. Perform external grooving operation. Step 27. Reset the workpiece. Step 28. Perform external grooving operation. Step 29. Perform external threading operation. Step 30. Check thread accuracy. Step 31. Perform parting operation. Step 32. Perform chamfering operation.